gentlemen, you are all welcome to today's short virtual seminar of the NSChE-HSESG group. My topic is Hazard and Operability Study. My name is Oyebanji Suli Adetone. I'm a member of the Nigerian Society of Engineers, member of Nigerian Society of Chemical Engineers, and also a lawyer in addition to the engineering profession. As a brief history, I've worked during my on-the-job training with the Warri Refinery and Petrochemical Complex, and I'm also one of the pioneer staff of the LMA Petrochemicals, where I was a process engineer and a process operator running the olefins plant. After which, we moved to the Shell Petroleum Development Company, in which have worked as a process engineer on different locations, and also retired as process safety engineer. So my presentation is just a little bit of awareness for some, and a challenge for me to also learn from the wide group of my senior colleagues, managers, and the peers. The screen we are seeing is just to bring us to one of the process safety incidences. Is a burnt wellhead in a remote swamp location in one of the major oil and gas industries. Now, technical safety engineering framework. As a sum of introduction, hazard is anything or any condition with potential to cause harm to people, harm to the facility, or harm to the environment. Hazard and its management is a primary issue for all the plants and facilities, driven both by company philosophy, local requirement, and external requirement. There are three main goals of safety engineering. First is to identify the hazards, and the next is, as much as possible, eliminate hazards if practicable. And where you cannot eliminate all, the residual hazards are mitigated upon. This forms the main task of focus of hazard management in both plants and industry. Now, why do we not eliminate all hazards? We cannot eliminate all hazards because they have some technical limitations sometimes, and even where they are technically feasible, you have to consider commercial and cost constraint. And of course, some hazards are tolerable. So when you look at all this, you try to minimize the hazard as low as practically possible, and then where they are tolerable, we leave the. Now, hazard identification. There are so many tools to identify hazard. This is done using various tools. For example, hazard identification. You also have risk identification, and so on and so forth. These are done at different stages of the project, starting from concept to operation, decommissioning, and abandonment. Why do we need to identify hazards? Now, we identify hazard so that we will not be caught in the process of operation and decommissioning. When we identify the hazard upfront, starting from the front-end design, we try to design them out, and where we cannot design them out, we put various safeguarding measures to be able to control them and also to prevent the impact if it eventually gets released. Safety in design. After identification of the hazard, part of the design is consideration of the safety. Safety in design is the use of applicable engineering standards, both local, external, and company-wide, to engineering designs with the aim of designing out hazard to as low as reasonably practicable. All facilities are expected by law, both the national and international law, to be designed by certified engineers, which me and you all. Failure to design and construct to a lab is criminal and attract various levels of sanctions. Most time, professionals get away with sanctions due to failure to design and construct to a lab because of the level of awareness of our other developed or developing countries. But as time goes on, especially now that you have more lawyers going to engineering, it will become difficult for us to escape, because most times why we escape is that the prosecutors, they are not versed in the nitty-gritty to prove beyond reasonable doubt in the courts of law. Now, the hazard and effect management tools consist of a package of tools through which we eliminate hazards during the front-end design. Then, where we cannot eliminate all the hazard, we put control and safeguard in place, both to mitigate against the impact to tolerable level. Here are list of some of the tools. First is the hazard, then the Hazop, hazard and operability study. We have the fire plan, which what it does is after our layout designed and the process flow script have been completed, you go carry out a fire plan, that is fire analysis, to see the effect of possibility of release of fire and the mitigations, just as we do for Hazop. HSC case study, all this looks at the specific hazard and come up with all kind of serious incidents we can have, carry out mitigations and put mitigation in place to be done on each of the unit and equipment. Both are analysis. Ergonomics. Ergonomics have to do with how equipment are handled and how human beings that operate the equipment, so that you don't put a valve too high or too low that force the operator to have to bend or walk undergrade and or walk on the unnecessarily tall ladders. That is the work of ergonomics. Environmental impact assessment has to do with, we already covered that the previous session, so I won't go into that. Plant layer review. We look at that so that you see the interaction between one plant or the other. For example, if there is fire in one equipment, how close is the other one for the fire to get in pitch on it? All this, you look at the plant layout. You also look at the easy accessibility of one equipment to the other, how cranes can move around, how human being can carry things. You have to move equipment and so on and so on. These are what plant layout does about. QRA, quantitative risk assessment studies. Then safe handling of chemical, which was handled by our senior colleagues last week. They have a host of tools, but today we just pick one of them, which is the Hazop, and we will see why we have picked an Hazop. It's not because it's the most important. None is most important and none is least. They are all integrated set of tools which are necessary for us to enhance and be sure that our plant is designed to as low as reasonably possible. And in fact, there is a concept that if our plant is safe, we should be able to carry our family to host a party within the plant. If we cannot do that, then we should question ourselves. Now, Hazop, what is Hazop? Hazop simply is hazard and operability study. It's a structured hazard identification and management tools using a multidiscipline team and approach. It is structured, is a highly specialized area, and all it does is for us to be able to identify all the hazard, and then we'll be able to come up with possible safeguard and control so that we are sure that our plant will be able to start up heat-free. And when it started up, we ensure that it's not going to have a showstopper that is get it shut down. And when we want to decommission, we will not have problem. All these are what Hazop contain. Then Hazop can be used, applied to existing facilities. Okay, it's mandatory after 5 years of operation. It also applied to new plant, and as we shall see, it's so versatile. You can apply it to procedure, risky procedure, and so forth. Now, what are the strengths of Hazop? Hazop is the principal method for identifying hazard and operating problems using the experience of the leader and the multidisciplinary team members. It is very versatile and applicable to management of hazard in new and existing facilities. It is applicable in management of hazard in risky operation procedure. When I was with SPDC, they actually applied it. We have an incident, a very serious incident during one of the well testing procedure. And we were called in and were able to carry out Hazop on well test procedure, which was novel. Okay, it's not been done before. We don't have record, but it was well acclaimed and very successful. And we tried to push it forward and give it out to all our contractors who carry out well testing and during rig drilling and so on and so forth. If properly conducted, Hazop manages potential showstoppers during startup and operating phases. Yes, after all design and installation, you carry out pre-startup audit. But even before pre-startup audit, if Hazop is carried out and led by an experienced Hazop leadership, you'll be able to go into the area of pre-startup audit and identify any major showstopper. Also, we dwell into things like what could be the possible major critical spare parts that needs to be stocked. Now, what are the Hazop weaknesses? An effective Hazop study is dependent on the team, the technical knowledge and experience, as well as the competence of the leader. It is garbage in, garbage out. The Hazop report or study is as good as the experience and competence of not only the Hazop leader, but the entire team. The Hazop team cannot identify hazard or foresee causes that are outside their knowledge. What do we mean by that? And it's good, it's a structural approach, but because of the brainstorming session, if you don't have experienced operators, experienced design engineers, experienced leader, you will not get and identify all the key hazards. Hence, the preference for Hazop leader and team with wide range of process engineering knowledge is paramount. Now, what are the methodology? The methodology for Hazop starts with a multidisciplinary team is nominated. Because of the importance of the team, the first thing an Hazop leader will do is to sit with the management, get list of the multidisciplinary team, get their experience screen, and get the concept of the management so that they will be ring-fenced during the time of the Hazop. After that, you get the process flow scheme or process engineering flow scheme of the plant, or if it has to do with the operating procedure, for example, the well test operation, apart from getting the testing rig layout, you get details procedure, and then you divide the plant into manageable flow nodes using the process flow scheme or process engineering flow scheme or procedure description for procedure Hazop. And the nodes are listed in the Hazop pre-worksheet for the Hazop team. What are we saying? We get the process engineering flow scheme or the procedure description. The Hazop leader, based on his experience and based on the support, you need to have a host who will be a link, who's experienced in the plant. They go through together, break up the plant into different nodes, manageable nodes, so that you can see where the flow originates and terminates. Then you list all those into different nodes. You can have as many as, even if possible, 200, 1,000, depends on how complex it is. But the good thing is that you, just as you want to carry out your mass balance, you look at a particular node at the starting point, and you see where you can carry out a reasonable mass balance and end it, and that form your node. Then you break them up. And since they are all well documented, no part of the plant will be left out. Then the Hazop process is the systemic application of combination of parameters. What are those parameters? They are the primary variables in our thermodynamics. We are talking about the flow, the height, pressure, temperature, and then you apply the guard words: no flow, more flow, less flow, and so on, to produce deviations. What do you mean by deviations? Normally, you design our plant either to have a flow, or you decide particular section not to have a flow. Probably you want to have flow only when you want to depressurize. So what will be deviation? If you decide for a flow, a deviation will be no flow. A deviation will be less flow than you design it for. A deviation will be less pressure or more pressure than you design it for. And where it's meant only for decommissioning or depressurization, during normal operation, a deviation will amount to where you have flow. So all these are what you will list. And next, you go to the credible causes of the deviation. For example, what will make you to have a higher increase in pressure? You brainstorm, document it down. After that, what will be the potential causes of this deviation, with the assumption that there is no protection? Normally, you design with protection. But during Hazop, in order to look at the consequences, you assume no protection. So what will make you to have sudden increase in flow or sudden reduction in flow without consideration of protection? So when you look at the potential causes, that is documented. Then after that, you now look at what are the protection you have. What are the existing mitigations? And then you ask yourself, this existing mitigation, is it enough to be able to help us to have a lab? So that if we bring our family, for example, if I invite my great and long time and father of all MD, Engineer Shoyode, to come and have a party with me inside the new refinery, will he be convinced that the existing mitigation is adequate? If it's not adequate, then we throw it open. What further things can we do? So those further things form the recommendation of action to be carried on. If at the design stage, beautiful, all you just need, we pencil it down, then whoever the designer will go on and add those. Of course, I don't want to go to how do we measure whether it's adequate. We go to our hazard and effect, the risk table, the risk matrix. You go, I don't want to go into that. That could be a topic for another time. When you look at the risk table, you look at the low, medium, and high, and so on. If it is medium and high, you have to do something. But when it is low, you may not bother. But if you can still do something to even move it to zero without adding too much cost, then we do it. So all these form the recommendation for the Hazop. After that, we come out with a worksheet. Of course, the Hazop team, we have a secretary. Every of our discussion is documented. And before we leave, it come out, it document them, and first thing the following morning before you continue, he shared the worksheet with all members of the team. And where they think anything has been left out, it is updated, just like minute of meeting. Now, the Hazop team I talk about, as we said, is a multidisciplinary team, and the experience competent of the Hazop and so on and so forth. We're not going to that. So this form the particular theme. Now, what are the deliverables? After we carry out the workshop, the brainstorming, and the Hazop secretary have documented and produced the worksheet, there are two major deliverables we expect from him. The first one is the Hazop study worksheet, and it's a set of detailed minutes presented by the secretary and reviewed by the entire Hazop work team. And once that is agreed, that forms the basis for the report. The second deliverable is a detailed report of the Hazop team leader containing an appraisal of the subject of the meeting and summary of the main action points. Now, let's bring it clear. As I said, the Hazop study report is as good as the competence and experience of the Hazop team members. The worksheet that's produced by the secretary is owned by all members. You cannot deviate from it. Once the worksheet is okay, the Hazop team leader is exonerated at law. All the members of the Hazop team, they may be held responsible. However, they are working on behalf of the management. By the time they pass their report, the management can add more, but they are not necessarily allowed to tamper with the worksheet. Now, the worksheet belongs to the Hazop team members. The Hazop report is generated by the Hazop team leader. It will include the worksheet verbatim. However, there could be instances where the Hazop team members who have the project management team members in place can feel that a particular safeguard, which is low or medium, is adequate. The Hazop team leader, based on their experience, can come out with a higher level of protection. And whatever he put is owned by them. It's not answerable to the management. It comes to protect its integrity and its wide experience. There are times that the Hazop team leader could have worked with other competing companies. He could also have worked in US, UK, Cameroon, and so on and so forth. Even if his experience there is not known in Nigeria, or if he goes to Hazop in UK and the experience in Nigeria is not known there, he can bring it up, even when it is not considered. What I'm saying is that why the team leader cannot doctor the recommendation of the worksheet, if he has another information when he's preparing the report, he's free to bring it in. Now, this is a typical process worksheet. As we said, if you expand it later, you will see that, for example, where my cursor is can be the beginning of a node. Of course, I would have having the process description of the entire plant. Of course, we deal with different plants. So the first thing up front before the Hazop start is the team leader. We have detailed discussion with the project sponsor, where they forward to him the process description, the operating procedure, maintenance, the commissioner, and so on. This will guide him to be able to select effectively his node. A node could be from here down to this place. And where it is, where you have a vessel, you can be able to, you may decide to break up the node into the liquid part, into the gas outlet, down to probably the relief, and so on and so forth. You can take the drain line down to maybe the salt vessel, and so on and so forth, manageable nodes. But there is no hard and fast rule. But the important thing is that a good team leader will be that who does not only have experience in design, but also have operated plants, wide plant, for example. That is why by the time some of us become, lead Hazop, it becomes a little bit controversial. It becomes challenging on those who have only worked in oil and gas, for example, or if you go to the downstream, if you have something in a refinery and you bring the experience of oil and gas in, you may be looking at being hard. But as I said, this is what you start with. You have the drawing, and then from there, you break up your notes, you agree on the notes, you share it with the team up front, so they know this is what they are going to work on. And each team member is expected to do detailed study of the drawing and the note. Now, all the story we're talking about, this is sequential of the Hazop studies. You start with the HSE hazard identification. After identifying the hazard, you go to quasi Hazop. Quasi Hazop is usually done at the point where what you have is just the block diagram or the process flow scheme. By the time you proceed in the front-end design, you carry out the main Hazop, okay? And before you commission, when you completed your detailed design, you do the final Hazop. And then, of course, after the final Hazop, when you commission, you do the further process hazard analysis, which is the re-Hazoping after 5 years, okay? So this gets us the flow scheme, okay? And now, all what I've tried to discuss about the methodology of the Hazop are captured here. You have the selection of the nodes, you have the deviation, no flow, less flow, more flow, and so on and so forth. You go to the causes, brainstorm the causes, you document the causes, you ask yourself, is that cause possible? If yes, then look at the consequences. If no, you go back to another deviation and you repeat like that, okay? Then you look at the causes. Do you have barriers in place? Yes. Can this barrier fail? Yes. Does it matter if it fails? If all your answer is yes, then you go to recommendation. Or another thing is the barrier adequate? If not, then okay. If it cannot fail, then you go back to deviation. And so this is what to, then this recommendation, as we said, the entire process is captured in the minute of the Hazop, which is honed by the entire Hazop team. And then, of course, this is how to come up with our deviation. You have the variable parameters here, the flow, pressure, temperature, level, phase, composition, and so on and so forth. No more or less you apply to this. So you have the list of deviation. You go step by step. So Hazop is really a bit tedious, but painstaking. And when carried out properly, it saves both the plant, the operators, and the environment from hazard releases. Now, this is a typical worksheet that we talk about. And then you can see we start with guide work, no, and then we look at the parameter, flow. What could be this is deviation, no flow. What will cause no flow? One of the things that fuel gas system shut down. Okay, if it's shut down, what are the consequences? You have overall plant shutdown. You have no port gas, to flare. Then what are the protection? When we are capturing these consequences, you assume no protection. So you just put it down as it is. Then the next thing, you look at the protection to prevent air, ingress into the flare. Okay, you have to introduce purge physically and so on and so forth. Then you ask yourself, is this adequate? Okay, what could be effect if you don't have purge gas in the flare. You have explosion and so on and so forth. Is this protect? If not, then you come out with this recommendation. And then who will do it? You capture it. And then this is to tell you the number. You number each of the recommendation so that when you capture it, by the time you carry out closeout action, actually the management, they take priority on this. Before you can go to the next step of your design, it is mandatory that all this should have been captured and close out. Of course, when you do the risk matrix, you put a timing. There's some you have to do before you produce. For example, some that could be just ordinary operation procedure. You don't need to do that. You can do that before the operation, the plant is commissioned. Thank you so much. Hello.